Okay, so let's get ready for the last lesson of chapter 6, which is lesson 6.5. We have two problems of the day. Once again, pause the video and work on them. So the last lesson in chapter 6 is entitled Graph, Square Root, and Cube Root Functions. So let's start talking about what the parent functions are. So we did a lot of talking about roots and radicals, so on and so forth. So we're going to finish up with actually graphing them in two types, square root and cube root functions. All right, parent function is a really basic function. If you look at the square root function, f of x equals square root of x. The cube root function, f of x equals cube root of x. So there's no other numbers, it's just a square root or a cube root of the letter x. Well, how I like to streamline it, and there's multiple points that you could pick, but I found it over time easier if I give you a guideline to plotting them. So what I would say for my table for square roots, I'm always going to pick 2 points. So let's make our little XY table. I'm going to tell you to always pick for square root ones 0 and 1. Now if you notice, I didn't pick any negative numbers, right? I start off with 0 and then I did 1. Can you remember why I'm not picking a negative number? The reason is, if I take a square root of a negative number, it's imaginary. So there's a restriction on square roots, which are even roots. So I'm only ever going to use 0 and 1. So every time you see a square root function, pick 0 and 1. 2 numbers. Obviously, I could pick more than 2 numbers. We need at least 2 to sort of see what the graph's going to look like. All right. So it's square root. Let's plug in 0. Square root of 0 is just 0. If I plug in 1 for x, square root of 1 is just 1. So let's take a minute, plot those points. Here's 0, 0. Here's 1, 1. Now, here's the downside. I'm only making you do 2 points. So if you look at first glance, this looks a lot like a straight line. It's not. If you pick more than 2 points, the more points you pick, the more you'll see the curve. But what a square root function looks like? It's sort of like a hook or a curve, like that. It has an endpoint. Remember, I can't pick any imaginary numbers. Negative gives me imaginary solutions. So it starts at that point and curves over. So there's only one arrow. Now, to talk about domain and range, D for domain. Let's use this color. There is a restriction. If I take my pen right here, or my cursor, x goes up and down. I start at 0, and I work my way to the right. So x is greater than or equal to 0. And we talked about things like that when we did domain back in section 6.3. Now range is y. Y goes this way. It's horizontal, right? So where does it start? It starts at 0, just here, and we work our way up the positive direction. So it's y greater than or equal to 0. All right. Now off to cube root functions. What I like to do for cube root is I'm going to pick 3 points. So this is your little rule of thumb when you're doing these. I always like to pick -1, 0, and 1. All right. I can have a negative, right? Because cube roots have I can't have negative numbers. Negative, 0, and positive work. For square roots, only 0 and positive numbers work. All right. So plug in -1. Cube root of -1 is still -1. Cube root of 0 is 0. Cube root of 1 is 1. Let's plot our points. Now once again, you could use these points over and over depending on if you have a square root or a cube root. Pick 0 and 1 for square root, pick -1, 0, 1 for cube root. Here's the issue though. Once again, I do not have a lot of points. It looks like a straight line. It is not. So what's going to happen is we're going to curve almost like an S through them. Very slight S. And I'm not going to be picky. Just try to draw it as best as you can. Actually, I think I want to fix this one little spot here. Let's do this. Do under over differently. All right. So we'll go up. We'll go that way. Put more of a curve. All right. So that's the basis to a cube root function. Now, domain and range, you're going to like cube root functions because they're both all real numbers. There's no restriction on cube roots. All right. So square root looks more like a hook, starts with an endpoint and then ends with an arrow, and then cube root has more of a curve. Actually, I find out I'm sometimes a perfectionist. Sometimes I like it more like this, so it curves a little more. All right. So let's actually take a look at an example. So we're going to graph y equals negative 2 square root of x, state the domain range, and we're going to compare with the graph of y equals square root of x, which is this one. We're going to talk about how this one compares with it. All right. So once again, make your table. I have a square root, so what am I going to use? 0 and 1. You could do that for all of them. Now hopefully you could evaluate at this point. I will do at least one with you. Plug in 0. Square root of 0 is still 0. So negative 2 times 0 is still 0. So that's how we're evaluating in case you get stuck. If I plug in 1, square root of 1 is 1. 1 times negative 2 is negative 2. So plot our points, 0, 1, negative 2. Now remember how it curved this way before? Here it's going to curve like it flips almost. Something like this. It's our graph. Now if we go back for a second to compare it with the graph of y equals square root of x, do you see how this one curved up this way? If you look here, it looks a little narrower and it flipped down. So that's how it changes from the parent function. Now, domain, I start here, it's vertical, x goes up and down, and then I go all the positive directions. So x greater than or equal to 0. Range, watch where your range is this time. It starts here, and what happens? It goes in the negative direction, right? My graph's on the negative half of the plane. So it's y less than or equal to 0. Example 2, graph y equals 3 halves cube root of x, state the domain range, compare the graph with the graph of y equals cube root of x. All right. So we have a table again. Think to yourself, what do I use for a cube root? Cube root, we use 3 numbers. We're going to use negative 1, 0, and 1. Plug them into the original function. I will do negative 1 with you. Always do the root first. Y equals 3 halves. Cube root of negative 1 is just negative 1. 3 halves times negative 1 is negative 3 halves, which is the same as saying negative 1.5. So you get negative 1.5. Sometimes you get decimals, that's okay. I think it's easier just to use the same points over and over as opposed to trying different numbers to make the y whole number. If I plug in a 0, cube root of 0 is 0. 0 times 3 halves is just 0. Plug in 1, cube root of 1 is 1. 1 times 3 halves is 3 halves, or 1.5. So plot your points and estimate. See, make sure it's sort of, it's hard to see, I know, but it curves through like that. More like a light S. There's my graph. Domain and range, once again, you're going to like these ones for cube roots. They're both all real numbers. There's no restrictions because if you take a look here, there's 2 arrows. They go forever in both directions. If I could type today here. How does this compare with the graph? Back 2 slides. It's the same thing, it's just stretched out a little more if you see. It's stretched out this way a little bit more. All right. So now we want to add a little bit more to it. What happens if I have extra numbers? So right now we were just graphing one like number 1. Y equals a square root of x, or y equals a cube root of x. What happens if there's an h and a k, some other numbers there? All right. To graphs of radical equations. To graph y equals a square root of x minus h plus k, or y equals a cube root of x minus h plus k, follow these steps. Step 1, we're going to actually simplify it and only sketch the graph of everything, taking away the h and the k. Y equals a square root of x, y equals a cube root of x. Then 2, we don't get rid of it completely. When we're done, we translate the graph horizontally or vertically. H is the horizontal, left or right. Y, or the k, is vertically up or down. Now you've seen h and k before with absolute value graphs. You've seen them with quadratics. A lot of times they were your vertex, so this is a little slightly different. All right, maybe a little familiar. All right, so let's see how we apply the next one. Example 3, graph y equals 3 square root of x plus 2 minus 4. State the domain and range. All right, so here's a little, make sure the tail end is there. You do not have the negative 4. We now first want it in this form for step 1. If you go back to step 1, it says simplify your equation. And I'm just showing you the square root one because it's a square root. We want in the form y equals a square root of x. So we want to simplify our original problem. That'd be what? 3 square root of x. All right. So that's what we're going to graph first before we do anything else. Step 1 is to simplify it to that form. All right, so now square root, what do I pick? Think to yourself. I pick 0 and 1. I'm going to plug it in here. If I plug in 0, so I'm not going to show the work, so just make sure you're listening and pay attention. The square root of 0 is 0. 0 times 3 is still 0. Plug in 1. Square root of 1 is 1. 1 times 3 is 3. So we start off by plotting our 2 points of our modified graph. And then hook curve it through like so. So that's our graph. Now, step 2. We didn't get rid of the h and the k. We omitted them at first to get a basic sketch, and then now we're going to take them into consideration. Do you see how inside the root it's x plus 2? Set that equal to 0. And we've done this multiple times with absolute value graphs and quadratics. So I take inside the root only, set equal to 0. I get what, negative 2? Just so you know, that's your h. Now h moves in the x direction, so h is going to move left or right, right? So if it's a negative 2, what does that mean? Left 2. So that's how we're going to translate the h. Let's think about k. K is the number off to the right. K just equals negative 4. So once again, the h is the opposite sign of what's in here. So I set it equal to 0. The k is off to the right as is, so it's negative 4. K or y goes either up or down. So if I have negative 4, that would mean down 4. So what we actually do now, let's do red. I have my basic graph, but that's not my final answer. I now have to go take my 2 points, move each point left 2 and down 4. I have to translate them. So left 2, down 1, 2, 3, 4, plot your point. Left 2, down 1, 2, 3, 4. As best as you could curve it, you're going to curve it a lot better than me. It should look like the same thing just shifted. That's going to be your actual graph. Let me fix that a little. Like that. Now if you want to, you could get rid of this first one. This black one is not your answer. The graph that you have to answer to, or your final answer, is this red one here. So now let's talk about domain and range. Now be careful with your domain. So domain is x. Do not look at the black one at all. It's off the red. So let's go along the x-axis. Where's the first point we see at? we see at -2, right? So once again with the domain, if we take a look here, it starts actually with our h or our k. We start here at -2, which is -2 from there, and we go to the right. To the right is greater than or equal to. So x greater than or equal to -2. Range, we start down here at -4. So here's -4. And once again, it's based off my k. And then I go up, which is greater than or equal to. So y greater than or equal to -4. And that's how we do our domain range. All right, so let's take a look at another example. Example 4. For example 4, once again, we're going to take a look at simplifying it. We want to get it in the form, step 1, y equals -5/2 cube root of x. So we're getting rid of the h and the k for now. We're only keeping the a in front. So this is what we're going to graph first. So if you remember, when I have a cube root, I'm going to use -1, 0, 1. I'm going to plug that in to this piece here that I rewrote. Cube root of -1 is -1 times -5/2 is 5/2, or 2.5. It's positive. Plug in 0. This cube root of 0, 0. 0 times -5/2 is just 0. Plug in 1. Cube root of 1. 1 times -5/2 is -5/2, or 2.5, -2.5. So plot these points. Estimate where they go. All right. Now from here, we still have to take care of the h and the k in step 2. So I set the inside equal to 0 to find my h. X minus 2 equals 0. So what's inside the cube root? I get x equals 2, which is also my h. So 2, think about what direction I move. X is left or right? It's going to be right 2. Actually, I'm going to type this part. Probably should have typed this already. Take a look at k. My k is the number off to the right. It does not change signs. It's just 3. K goes up or down. If it's positive 3, it's going to go up 3. All right. So let's use our red pen to graph it. Take each point. We're going to go right 2 and up 3. So right 1, 2, up 1, 2, 3. Right 2, up 1, 2, 3. Right 2, up 1, 2, 3. So that's my shift. And I'm going to curve it out this way. Curve it under this way to get an S shape. Now think about domain and range. This should be easy for us because you should actually like all the cube root ones because there are no restrictions because there's arrows in both directions. So you have all real numbers for the domain, and range is also all real numbers. All right, that's it for today. What I'd like you guys to do is work on the 2 problems of the day and then complete the following problems from assignment 13, numbers 1 and 9.